Hello everyone. Thanks again for coming to the latest in our Lab Chart Mastery Series webinars. Today's topic will be about our neurophysiology analysis tools. Specifically, we're going to be talking about scope view, peak analysis, and spike histogram. My name is Brandon Boucher. I am the Research Product Manager and Support Manager in 80 Instruments in North America. I'm going to be taking you through those topics today. Go to the next slide here. So the way the webinar is going to work today, all the audio from the attendees, those of you that are watching the presentation, will be muted. I won't be able to hear you speaking. So if you have questions, go to the GoToWebinar toolbar there, and you can type your questions into the questions area. We will go through the presentation. I'll show you the things that we're going to be discussing, the scope view, peak analysis, and spike histogram. Type in your questions there as you have them, and we'll come back to them at the end of the presentation, and we'll go back and answer those questions as we can. So go ahead and type those in there, and we'll address those later on in the presentation. Before we get started in talking about today's topic, I'm going to talk about a little bit about what we have coming up in terms of our training. We have a couple of outside workshops that we're going to be doing here. We're going to be doing one in Calgary. That is the data acquisition and experimental techniques workshop we'll be doing up there. We have a few spots left, so if you're interested and you're in the area, look that up and speak to your sales representative, and we can talk to you more about what's going to be going on at that workshop. We have another workshop we're helping with at the Jackson Laboratory in Bar Harbor, Maine, and that's the 13th to the 18th of May. That's comprehensive cardiovascular assessment in mice. And then we have, of course, our lab chart training courses coming up, one in May 14th and 15th, and one in May 22nd and 23rd, and we have one scheduled for June as well. Look at the calendar. We will be putting more of those up in the coming weeks for the following months. If you're interested in these webinars and you get a lot out of them, what you're going to see at those lab chart training courses is an expanded version of what you're seeing now. You're going to get hands-on training in all of these different features in lab chart. And we'll be there in person to help you walk through all of the different questions and the different features that you'll be utilizing in your lab. So if you're interested in looking at those trainings, go to our website, 80instruments.com/events, and you'll find more about those there. A little bit more about the webinars we're going to be doing here in the future. We're going to be doing one on the 21st of May that's going to be calibrating your respiratory flow and using the spirometry extension. And then we're going to be doing a sort of a fun one on June 6th. We'll see how that one goes. But that one is going to be useful features you don't know in LabChart. And that's going to be some of the last few things that I learned in LabChart, just little tricks that have helped me out, and nice little features that it took me a while to find out they were there. So these are things that don't necessarily fall into some of the categories that we have for our webinars here. So we're going to be covering a lot of those different little tricks of the trade in LabChart, and hopefully we'll have a lot of fun with that one. So if you're interested in more about the training we're offering, again, you can go to 80instruments.com/events and find out more. Before we get started here, one more thing we need to talk about: the statement of intended use. Basically, these slides are simply to say that 80 Instruments products are not intended as a medical device. They are meant for research and teaching applications only. That is to say that no product supplied by 80 Instruments is intended to be used to diagnose, treat, or monitor a human subject. That being said, when used with some of our isolated front ends, our systems are protected and safe for human connection for research purposes. We have some of those front ends that have the body protection or BF symbol, and some of those that are suitable for direct cardiac connection and have the CF symbol as well. All of our systems, all of our products are manufactured under a quality management system, our nice ISO 9001 quality system. The scope of that certification is design, manufacturing, sale, and servicing of data recording instruments and software. So going beyond that stuff and getting into the the reason you came here today and the topic of our webinar, and that is to talk a little bit about what we're going to be doing today. First, we're going to be talking about the scope view. I'm going to show you a few of the different ways you can use the scope view and sort of introduce that to you if you're not familiar with the way the scope view works. We'll be talking about that and hopefully give you some, get you guys going in the right direction as far as the scope view is concerned, and see if we can address any questions you might have about it. We'll also be doing peak analysis and covering a number of the analysis types that peak analysis can do. There's certain changes in peak analysis when you choose these different analysis types, and so we want to talk about the differences between them and look at each one individually and sort of get a good understanding of what peak analysis really does. Peak analysis being a general analysis tool that looks at peaks and gives you some information, but each of these types of analysis that are listed under peak analysis can do something different for you, so we're going to look at that. The last thing we're going to do is we're going to look at spike histogram. So we're going to do some spike sorting. We're going to use our template matching algorithm in order to sort those spikes, and then we're going to talk about the different analysis tools that are available in spike histogram. So that's the idea. That's what we're going to be going through today. So let me switch over to lab chart here. So lab chart should come up for you guys here in a second, and there it is. What we're looking at here is the scope view. So I like this presentation or this data file because it gives you a good overview of what the scope view can be used for and sort of its purpose. What this file is showing us is this is a classic evoked response where we have a stimulus and a recorded response that we can see 3 prominent peaks in. And as we move through, you can see I'm scrolling through the different pages here in the scope view and highlighting a different page there in yellow in the scope view. All of the other pages that we've recorded are overlaid, so we can see all of them at the same time. And again, this is just a great representation of what the scope view is intended to be used for, is simply, as we use different types of stimuli with this recording, we can see the changes or the differences in the response that we're trying to record. We can overlay those, we can average those, we can do many different things in the scope view after this point. But again, this is a great representation of why we use the scope view and the type of visual images that you can actually get from this. Well, what I'd like to do first, before we talk more about this file, we'll come back to this here in a minute, is I want to talk about the way the scope view is set up. There are 3 different modes in the scope view. If you look at this list here, we have block mode, event mode, and comment mode. And I'm going to talk about each one of those, hopefully a little bit briefly, and introduce you to the way these work, and sort of hopefully give you a little more comfort on how you might set this up. So to do that, what I would like to do is switch over to a different file. I'm going to close this one, and I started a new file here that I'm going to use to show you how this works. So in this file that I've created here, this is a data file that we use. You can find this data file in the Welcome Center under Getting Started, and you can use it as a little tutorial for using the scope view. I've modified it a little bit just so that I can use it for teaching purposes here today. But what we're looking at is in channel 1, where we have a light meter that is measuring the amount of light being shined into someone's eye. In channel 3, we're actually recording an evoked potential from the visual cortex, and that cortical potential that we're getting is recorded alongside of the light that's being shown to someone. And as you look at this data file, you can pretty plainly see the stimulus in channel 1, and looking down at the the cortical potential we have down here in channel 3. It's difficult to necessarily see any correlation between these stimuli and these events. And so what ScopeView is going to do for us, it's going to allow us the ability to average those events and really take out the noise that's in this recording. So to get started, what I'd like to do is first talk about block mode, because when people are familiar with the way ScopeView works, that's typically what they're used to seeing is the way block mode works. And we're going to move into the other modes and talk about why they're different. But first, we'll introduce you to block mode. So in order to set up block mode, this is a short segment of the recording. If you look at it, we have this stimuli here in channel 1 and the response here in channel 3. What I'd like to do to set up block mode is I'd like to set it up so that I'm only recording sections of data just before my stimulus to just after my stimulus, so I can look for the response. Okay, so I want to record just that little area. So the way that I'm going to do that is I'm going to go to Setup, and I'm going to go to Sampling. What sampling is going to allow me to do is it's going to allow me to use channel 1 as a trigger. I'm going to trigger my recording at 2.6, and I'm going to use a pre-trigger of 200 milliseconds. That means that when I cross 2.6, I will record the 0.2 seconds or 200 milliseconds before that event, and a fixed duration recording from that point to 0.8 seconds total. Now the pre-trigger option, sometimes when I explain what that is, recording 200 milliseconds before the trigger happens, LabChart is not, doesn't have any predictive qualities or anything like that. What it does is it actually simply continuously monitors the data, and the data is always available to LabChart. So when it does see that trigger, all it has to do is look backwards at the data that it already has available to it and then make that permanent with the rest of the data. So what we're going to do is record this in blocks. We're going to record 0.8 second blocks continuously with a trigger on channel 1. So if I click start now, what we're going to start to see is each of those blocks being recorded as we had intended. Okay, so each of the stimuli are recorded, the data around them are recorded here in channel 3. And what I'd like to do with this data now is just look at it in the scope view. So to open the scope view, you can find that under the window area in the toolbar, and it's the second button here. So there's the scope view right there. I'll click on the scope view. And what we're going to see by default in the scope view simply is every page that we have recorded. If we look at that page, every page that we have recorded, or every block that we have recorded, because we set this up to record in block mode, is displayed here in the scope view. Okay. So what we can do with this now, there's a number of things that we can do. If we go back to the sampling dialog, you can see some of the options that we have. We see that we're recording a fixed duration for an infinite number of times. The other things that we can do here is we can actually, just take a look and kind of go through the pages, see each of the individual events. What I can do as well is make a selection of some events. I can average those events. Okay, so I have a number of these events here. I can average them, and I have those events now. What I'm seeing in the overlay or the scope view now is an average of each of those events. And you can start to see, even with just 11 pages, you can start to see the response happening right here in the evoked potential. If I unaverage these events and look at them individually, I can do that. I can look through each one, and of course I can overlay each of the events that have been recorded, and I can change the number of pages that are actually overlaid. So I can see the different pages overlaid and get a good representation of what's happening over time. Another thing that you can do with the block mode recording is you can do some automated averaging. Okay, so right now I had recorded each individual page individually. I had made a selection and I had averaged those pages in order to get my average event. Now, one of the things that I can do instead of doing the manual averaging is, as I'm recording data, I can actually continuously average those events. So I can scope average. I'm gonna scope average, we'll say 10 events at a time. So I'm going to make groups of 10. And if I hit start and begin recording again, what you're going to start to see is that instead of showing each individual page, we're going to begin to count. And you'll see that we're going to create groups of 10 rather than individual pages. In real time, as we're recording data, you can see a few things. You can see the live recorded and calculated average of the events, and that's shown here in red in channel 1. The average in channel 3 is shown in green. The overlaid, pages that are shown here are actually in pink down here in channel 3 and blue in channel 1, and those are the pages that are surrounded by this little bracket here. Those are the ones in the overlay. So now that I have a few groups here, you can see I have 4 or 5 groups of 10, which is great. It's exactly what I want. If I look at this information now, you have groups of pages. You still have the overlay. If I expand those groups, what you can look at, you can still see the individual events. If I look at those, this is getting a little bit more difficult to see. So what I'm going to do here is I'm actually going to use some of the features of the scope view to eliminate, or rather to change the way that we're looking at this data. So I'm going to go to the settings here. I'm going to change the 3D depth and the 3D angle and the saturation of these events. And so what that's going to do for me is separate them a little bit so I can see them a little bit better in terms of time. I'm going to increase the number that are overlaid. And so what I can do here is explain what we're looking at. So what we're seeing is the active selected page, page 6, page 5, page 4. That's going to be shown in red when we're looking at these subpages. The black one there, hopefully you guys can see the black one that's going through that. That is the average page. And the other blue ones there are the ones that are simply just in the overlay. Okay, so I can change the way that looks. I can come through, I can change the angle and the 3D depth. We'll come back to this feature a little bit with a different file, and it'll look a little bit nicer. It'll explain a little bit better how that works. But you start to get an understanding about how the scope view can actually use. The different pages of the different events are continuously averaged over time. So each of these pages that I'm looking at here show me an average, which is great. And the other thing that I can do, I can still go through at this point, and I can, again, average those events. Okay. And one of the nice things about the way that the scope view works here is now that I've created each of these, or now that I've created this average, I have my stimulus and I have my response. I can find the time difference, between my stimulus and my response here. Features start to utilize the scope view that normally would utilize the chart view. And one example of that is if we go to the datapad. The information that the datapad is now accessing or asking for, if I have data selected in the scope view, is actually coming from the scope view. So keep that in mind as we go along, that the datapad is going to extract information from the scope view if that's what we are intending for it to look at by selecting the data in the scope view. What I'd like to do now is just sort of show you the difference between what we're looking at. So you can see the chart view, which is the traditional layout of lab chart, and we also have the scope view here, which is what we're trying to utilize now. So you can see the difference in the two features. As I scroll along here, one of the things that I'd like to point out is, throughout this entire data file, we have typically pretty good data. One of the things that we see here, though, as we look through the chart view, is we have a point where there is some bad data, some data that shouldn't necessarily be used because it has an artifact in it. There's a point where somebody blinked and we can see an obvious artifact in this recording. If I click on that page, one of the nice things that happens is I click on that page in the scope view, or the chart view, the scope view shows me that individual page. We've gone directly to that page. If I click on some of these others, you can see we're going to these others, but the one I'm interested in is the one with the artifact here. As of right now, the one with the artifact is being used as part of, you can see that's being used as part of an average, which is something we may not necessarily want. So what you can do, because it's being used as part of the average, I can actually right-click on this page, and I can choose to exclude that page from the average. It gives me a very, very easy way of looking through these events, and I can look at them in the chart view, see if there's something wrong with them. I can click on them, go directly to that page, I know exactly where that page is, and I can right-click on it and exclude that from the average. It's a great, useful tool. What I'd like to do at this point, though, is I'd like to change the way we're actually identifying these events. So what I'm going to do is I'm going to go back to my sampling dialog. I'm going to stop triggering, and I'm going to simply record all of this data continuously. Before I do that, though, I'm going to select all of my data, and I'm going to delete that data for now. And the reason that I'm going to do this is because I'm going to record this fundamentally differently, and I don't want to mix and match the two different things. It'll look a little bit funny for you guys. So I'm going to delete this data, and I'm going to start over from scratch and act as though I'm recording this data continuously. So what we're seeing again is we're seeing the same thing. We're seeing our stimulus, our response, we have our artifacts, all of those things are there. The other thing that we have here is in channel 3 we're actually we have a cyclic measurements calculation that's simply showing us the amplitude of the recorded stimuli from the light meter. And what we can do with this is, if we look at that calculation, one of the things that, if you're familiar with cyclic measurements, one of the things that is you can create event markers and place those above your data. You don't have to have these there for this feature to work, but it is a useful imagery for me to explain the way this is working. In many of the features in lab charts, cyclic measurements included, but many of the modules will do this as well. They will create what we call events or event markers. Okay, these events in cyclic measurements, Spike Histogram can create these. Many of the modules can create these. These events can then be utilized in other features in lab chart. Scope view is one of those, and that's what we're going to show you right now. But there's also features like multiple add to data pad that can utilize the event markers and things like that. So keep that in mind always when you're looking at the different features in lab chart and you're trying to develop analysis protocol. A lot of the features in lab chart can utilize each other to really define the different places you want to analyze data. So these event markers are actually going to be useful for us when we're using the scope view. So we have a continuous recording here, which is nice. We can see all of the data, but then we can utilize the scope view to take this continuous piece of data and break it up into the similar events that we were looking at in the block mode when we were recording this in blocks. So to change this, what I'm going to do is I'm going to change the mode in the scope view to event mode. And if I click on event settings, one of the things you'll see is that it gives you an option for choose an event source, which is great. I'm going to record a similar time frame from what I had. So 0.2 before the event, 0.6 after the event. And I'm going to auto average again. I'm going to auto average 5 pages. Another thing that happens here is you have the ability to go into exclusions, and this is actually fairly important. If I go into exclusions, one of the things that I can do here is I can exclude pages from the scope view averaging options if they meet certain criteria. If I have a short subpage, a short subpage would happen when, say, I manually stopped recording before that subpage was over and it was too short. I can actually get rid of that. So I'm going to say when I get a short subpage, I'm going to get rid of that one. The other thing that I'm going to do here is I'm actually going to say when channel 3 goes below, we'll call it negative 100 microvolts, I'm going to exclude automatically that page. And that's what our artifact that we had earlier, the blink artifact, actually did. It went below 100 microvolts there. So I'm going to automatically get rid of that that page. So if you know those types of things are coming, you can set this up ahead of time and make your data just come out beautifully before you even have to analyze it on the back end. So you can see we've already analyzed a lot of this data. And one of the things you're going to notice is this page right here was excluded. We can hopefully maybe see why. And the reason why is this one's short. Let's see if we can find another one. This one has the artifact in it. So that one was excluded as well. So both of those, luckily for this presentation, I didn't really try and do that, but both of those subpages show you the different ways you can automatically exclude when you're doing the automated averaging. So as we click Start here again, and we continue to get our continuous data, what you're going to start to see is we get our continuous data, and if I hit stop here, you can see we have our different events that are found, automatically averaged, and we have all that information, which is great. I can check, and now that we have our different groups, we have groups of 5. Some of these are excluded. I can actually still average these groups and average those further. One of the things you might notice is that there's 2 different groups here still, even though I tried to average all of them. And the reason for that is because the event mode cannot average across different blocks. So that's something to keep in mind. If you want to average all of your events, you should continuously record. So looking through this is just another way to use the scope view using the event mode. Now, another thing that I can do is I can also use the comment mode. The comment mode would essentially, just like the way we're using these event markers, if we have comments, we can utilize those much the same way, and I'll show you a different in a different file how we would do that. So I've shown you many of the features here in the scope view. There's a few more things to take a look at, of course. If we're looking through and kind of navigating things, there's a few things. If I right-click on some of these pages that we can do, you have the option to select all sub-pages. There's also a lock-in overlay set as background page. So I'm going to actually talk about both of those things. There's also, I'll talk about both of those things in a different file. But there's also a rename. So you can rename these pages if you have a special page, something that's of particular interest. You can rename the page and call it a good example, or you can name it whatever you'd like. As we're continuously going through things, though, and we're continuously recording, one of the things that we can do, of course, that we've done before is look at the latest subpage. Okay, and that's what we're looking at now. We're looking at the latest subpage. This button down here will allow you to if I'm reviewing old ones here, which is what I'm doing, I'm clicking on these different pages so I can review old ones. This button down here, if I hover over it, it says toggle always show latest page while sampling. If I click on that, that's always going to show me the latest page. Okay, so it's a nice little tool to jump ahead or go back, and you can sort of review things otherwise. So that's a good overview of the scope view. Now I'm going to show you a couple more features. Of course, you can change the background in the scope view. The classical example of the scope view, or the classic use of the scope view. People will recognize this type of look versus the white look. So we give you the ability to change back and forth with that there. So a couple different options, but I'm going to move over to a different file to show you the last few features. It's a little bit more easy to show how that works. So we're going to go back to our Hoffman reflex, which is something we were using, which I showed you just right at the beginning of this webinar. What we're looking at here again is stimulus and response in different ways and in different amplitudes. As we go along in these different pages, we have different amplitudes of the stimuli, and again, as we scroll along, we can see the different responses. The other features that I wanted to show you, and this is a great way to show this, or this example is a good way to show this, is that I can actually, if I choose something that is, say, let's go to here. This is the first page that shows me my maximal response. What I'd like to do is I'd like to right-click on that, and I can do a couple of things. First, I can set this as the background page. If I set this as the background page, what's going to happen is all the other pages change, and now what they're showing is a representation of the page of interest subtracted by my background, or minus my background page. So my background page has been subtracted from the page of interest. So as I scroll along here, we're seeing something fundamentally different. So this is a great way if you have an example or you have a standard that you want to review the other pages by. This is a great way to do that. You can use the background page feature to subtract an example from all of the other pages. And of course, your data analysis from here on out will be utilizing that background example as well. So you'll be analyzing the difference rather than the absolute value. I can, of course, right-click on this and clear the background page. The other thing that I can do is I can actually choose a page to lock in the overlay. And I'm going to choose the same one. This is going to be my first page. It's my maximal response. And I'm going to lock this one in the overlay. Now, all of my pages are in the overlay, so this doesn't really mean anything to me yet. But if I get rid of, most of these pages, what we're going to start to see is that my page of interest is going to be always displayed in the overlay, and that's what you can see here. My page of interest is the one that's faded a little bit, or the one that I locked in the overlay is the one that's faded a little bit. And now I'm comparing one page to that specific page, which was my maximal response, and I can see all of these various changes, in direct, comparison to that one event, which is a great thing for me to be able to do. And then lastly, if I go back and I put everything back in the overlay here, of course, I'm going to go revisit the options that you have here for changing the saturation, for changing the 3D depth, separating the different images or contracting them and seeing them in different ways, and then changing the angle of that image. Okay, so you can see, you know, the various ways that you can actually visualize the different things that you're looking at. So the scope view is a great tool, you know, for you know, looking at different types of stimulus response type of recordings and various different ways you can look at these things. And it's you know, getting better all the time. Really proud of, you know, what we've done here with the scope view. So again, if you have any questions, type those into the questions area. But for right now, we'll move on to the next feature, which is going to be the peak analysis module. So to talk about the peak analysis module, what I'd like to do is open up this file here that I created earlier. And this is just simply an interstellar recording. We're recording some action potentials, and we're going to analyze those action potentials using peak analysis. So if I click record here, or start, you can see the action potentials will begin to come in again. And we'd like to analyze, you know, those larger potentials there with peak analysis. The way we're going to do that is we're going to go to peak analysis and go to settings. If we look at this, what we can do is now make sure that we are analyzing this in the proper fashion. One of the things that I wanted to mention in the peak analysis settings is the various analysis types, and I'd mentioned that when we were looking at the PowerPoint presentation earlier, that there's various analysis types here. You can see the default is general unstimulated, and what that really means is it's just a general tool finding peaks in general and analyzing them in general. And what really changes a lot of times when we choose these different analysis types, first, the detector can change depending on what we're trying to analyze, but also really the nomenclature of the things that we're trying to analyze, whether it's baseline, time to start, time to peak, amplitude of the peak, area of the peak, that type of thing. The names really change of those on those different, you know, features of the peak we're looking for depending on the type of analysis we're doing. So when we choose action potential as our analysis type, we get various you know, differently named analysis tools, and we get some other new ones as well, but many of them are very similar to the general analysis type. They just have different names. So, you know, what we do when we choose the analysis type, again, it changes the detector somewhat. It also changes what we're actually analyzing. So right now we're analyzing an action potential, so we're going to use this feature here. We're going to go over to the detector first. And under the detector, what we're going to do is we want to set this up so that we're detecting each of these larger action potentials, and we're not detecting any of the smaller ones here. And we also want to make sure we're not missing some of the others. So what we have is minimum peak height. Minimum peak height, if you're not familiar with what that means, a minimum peak height essentially is looking for a rise and fall. It's a double-sided height of at least 30 millivolts. So we'll see if we change this, if it actually helps us out in detecting some of these. So I'm changing that 20 millivolts. That didn't seem to help. And you can see that this is definitely larger than 20 millivolts. So the other feature that is here is this minimum detection width. That means that the peak has to be at least, you know, this wide to be detected. So what we need to do is, you know, change that as well. So I'm going to change this and kind of go back to my 30 millivolts, and we'll see if we can make it so we can detect each of these. So let's change this minimum width, and that is, we'll make it smaller and see if we detect some more of these. So now by making that minimum width smaller, we definitely detected each of the waveforms that we're looking for. So what we're basically saying is if this action potential isn't of at least a certain width, we're not going to be detecting it. We can measure detection width at half of the height, or we can measure detection width at the minimum peak height. So just different ways we can measure that. So that's detection. We've detected all of our action potentials, which is what we wanted. Now let's go through the other tabs here. Of course, you know, before we go through the other tabs, of course, we have to choose our source channel, as in all of our analysis tools. We also have to choose that we're going to analyze the entire channel or a small selection of data. So this is true for all of the modules that we have these two features. Looking at the resting membrane potential tab, this gives you the ability to define the resting membrane potential. okay, as well as the start and the end of the peak. So the resting membrane potential is either automatically going to be set, and the definition of our automatic is basically, if you go to the help menu here by clicking on this button, it gives you a better rundown or a better definition of the automatic setting that I'm about to give you right now. But it's basically, the first flat area before the start of the peak is where we are finding the resting membrane potential to be. Or you can always set the resting membrane potential to a certain level, so you can say that this particular level is the resting membrane potential, or you can use the minimum value between detected peaks. So you have different options there. You also have some calculations that are user-defined. For instance, the time rise, time fall, or the T rise, T fall in this table here are actually user-defined features. So the T rise is right there. The T rise says the time interval between peaks, the time interval for the peak to rise between two user-specific thresholds. So you're defining those parameters there. So you have some options there to define different types of parameters. And then lastly, in table options, you're going to choose which parameters you really want to see in the table. We click OK. We've analyzed that data, and then in peak analysis we get a couple of things. We get the analysis view and we get the table view. These two features, if I use my smart tile feature here, I did not use smart tile, that will there. Let's try that again. So those two features give me basically the rest of peak analysis. So what the analysis view is showing me is the live one that I'm either clicking here in the chart view, the live event, or the one that I'm choosing in the table view is shown here. And it's shown with various parameters that have been calculated. The start, the peak, the width, different parts of that are shown. The resting membrane potential is shown. And if you look through the table and you see something of interest that may look a little bit off to you, you can click on that and you can see, what's going on with this peak. Each of these look really good, which is great. The next thing that we can do with this now is we can do a couple of things. We can, with peak analysis, we can choose to analyze while sampling. If we choose to analyze while sampling, what that means is as we record and different action potentials are detected, they're going to be continuously added to our table, shown live in my peak analysis view, and we can in real time see these things be placed here. One of the other things that I want to mention about this while we're recording these things live is that in the scope view, again, we can use these events that are being defined by peak analysis as events that we can use in the scope view. So I'm going to make these really short. I don't know exactly where I need to set these, so bear with me while I sort of play with this a little bit. But let's see what that looks like. Yeah, I didn't do that well, but you can see each of these pages, utilizing the events from the peak analysis view, or from peak analysis. Again, we're recording all of this in real time. One of the other things that we can do with peak analysis, if I add a channel, and we can do this with many of our modules, and that is we can create a real-time, sorry, that was by Histogram, I meant to go to peak analysis. We can create a real-time calculation with any of the calculations that peak analysis can calculate. So what that means is, for instance, let's do area. So the area of these action potentials can automatically be displayed while I'm recording that data. And so as they're being detected, you can see, we're beginning to see the calculations show up here as well. Okay, and so that is, a great feature to be able to see as you're recording data, those things that you're detecting, and the calculations that you're finding are automatically being placed in another channel, and you can review those things as you're recording data, which is a great feature. So looking through peak analysis, just a few more things in here. These features allow you to clear the analysis, analyze the channel, basically just a couple of features to give commands to peak analysis. Going back to the settings, though, I just sort of want to talk about some of these other differences. If I look at general unstimulated, you have a detection area that looks a lot like cyclic measurements. If you're familiar with cyclic measurements, you have different definitions of baseline, various other calculations, and then a long list of calculations. So you have different features for the different types of studies you might be doing. If you're doing an evoked response, we have a way to find the stimulus artifact and find the response separately, and then various calculations that have to do with those types of features. So just looking at some of these other data types, for instance, this would be the evoked response. The evoked response again shows the difference between the detected stimulus and the response, and gives us parameters that are specific to that type of analysis. So again, peak analysis is a very general tool, can do a lot of different things, but it is just hugely versatile in terms of what it can do and how you can utilize it to really get the most out of your research, and make analysis as easy as possible for you. So again, that's peak analysis. So if you have any questions, again, feel free and type them into the questions area in the GoToWebinar toolbar. Otherwise, we're going to move on now to spike histogram. So moving on to spike histogram, I have set up another little file for us to play with, and that is this spike live data. So what we see here is an extracellular recording, and we're picking up spikes from various units that are near the electrode we're using to record. And what we're going to be doing with this, hopefully with spike histogram, is we're going to be taking a look at each of these spikes, and we're going to define them as being part of different groups or different units. And then we're going to be analyzing the firing of those different groups or units, and seeing, if there's any timing or correlation associated with them. So in order to do this, what we'd like to do is we're going to go to spike histogram, and we're going to go to settings, and we're going to look at channel 1. One of the things about spike histogram is it is a module that can analyze many channels at once. So if you have data in channel 1, you have similar data from another electrode in channel 2 and another electrode in channel 3, you can analyze and you can compare and contrast all of those different recordings, and make the same analysis that we're about to do here, just with data that's in channel 1, but we're going to do it in many channels. This data here is going to be a multi-unit recording, which means we're picking up spikes from various units. And to analyze this, what we're going to do is we're going to choose the data source. We're going to analyze the whole channel. We're going to set a detection threshold, and 200 millivolts is correct for this data, so we're going to leave that there. What this is telling us is my spike polarity. I do have positive spikes here, so I'm going to leave this positive. But it is important to note that if you were to choose negative polarity, you still want this detection threshold to be positive, because if you choose negative polarity and you set this at 200, that means that the detection threshold will be negative 200. So that's something to keep in mind, is that this detection threshold goes in the direction that you're placing this radio button. My pre-trigger and post-trigger interval has to do with the a different view in spike histogram that's going to display, after each of these are detected, it's going to display in the discriminator view the different spikes that were detected. And it's going to display 1 millisecond before my detection threshold and 4 milliseconds after, or 4 milliseconds total. And then we have a couple other options here. The template matching options we'll get back to. It'll make more sense after we do some template matching, and we'll go through and change that. And then the other thing we'll want to do is we'll want to choose whether our spike height is measured on a biphasic level or a monophasic level. So really all that means is if you choose monophasic, the spike height is going to use, the spike height and width are both going to use just simply the positive portions of the spike. If you choose biphasic, the height and width will use the positive and negative portions to calculate those things. So that's all that really means. But if I click OK, you can see that we've gone through, we've detected each of our spikes. If I go to spike histogram and I open up my discriminator, what we're going to see pretty clearly right away is here in the discriminator view, I have each of those spikes that were detected displayed very clearly. And then I have, in terms of width versus height, all of those, or height versus width, all of those various spikes are laid out in a scatter plot as well. And what that does for me is it gives me a very easy way to go through and start clicking on these. And you can see that there's very clearly one group of spikes here and very clearly another group of spikes here with two very different contours. So what I'd like to do now is I'd like to click on one of these, and I'm going to define one of these as being my template. And I'll use this one that I clicked on right here. You can see it shown in black. And in order to define that as a template, all I'm going to do is I'm going to click on that one, and then I'm going to go over here and I'm going to click Add Unit. And all that does is it goes through and uses that template matching algorithm to define that one unit I clicked on as the template, goes and sees the others that match it, and defines those as part of the same group or the same unit. Now that I've defined a unit, I can edit that. I can name the unit, I can change the color, but I can also change the fit tolerance. And what that does for me is that says, as we go along and I look at that template that I've defined, how well do the others have to match that template in order to be defined as part of the same group? So this is where you're going to change that value here, and I change that value to 70. If I change it to 50, we'll start to see some of these units dropped out because they will no longer be defined as part of the same group. I think the right level on this is right around 70 from my experience in this data file. So we've gone through and we've defined unit 1. The other way we can define a unit is we can actually simply draw a circle around a group. Okay? And this is another group that I'm defining right here. I'm going to click Add Unit. Now that group is being defined as another unit. And you can see if I click on each of these, you can see that it shows me how that was defined as part of the group. It shows me the contour that I used to define those. So now, another thing with spike histogram, just like many of the other features, if I choose Analyze while sampling and I start recording more data, now you can see that each of the spikes that are detected have either a blue or a red marker above them, which tell me, if I go to my discriminator again, that those are now being defined right away as part of my groups that I've defined earlier. Okay, so very simple to do, very nice features for defining those units. Going through spike histogram, I'm going to show some of the other features that we have here. We have the interspike interval histogram. This shows each of the units we've defined, and remember again that this can be done over multiple channels. Okay, so if you look at the discriminator view, right now it's just on channel 1. If I had analyzed channel 2 as well, I could choose channel 2, and then we'd be looking at information from channel 2. But looking at this in the interval histogram, what this is showing us is during my recording, we have at time 0 being when the last time unit 1 fired, you can see what the interval was between unit 1 and the next time unit 1 fired. And you can see one of the clear things that we start to see out of this data particularly is that very often when unit 1 fires, we don't see unit 1 again for a short period of time, and then we very often see it fire as a doublet. So we see it fire and we see it fire again in a very predictable spacing, and that's what this is telling us. We don't have similar information about unit 2, but what this basically gives us is the ability to analyze, the timing of the firing. If unit 1 fires, does it fire again? Other options that we have here, you can change the way these histograms look. You can change the bin sizes, raise and lower those bin sizes. You can, of course, go through and change the scaling. You can also page these events, which basically means that instead of having one plot, I can break it up into multiple plots. And the way that I do that is either have a plot per block. If you're familiar with the term block is when I stop and start recording. I can have a different plot each time I stop and start recording, or I can have a different plot for a fixed duration of 1 second. And so what this means is now I have 18 seconds worth of data. I have 18 various plots. Okay. So that's what I can do with each of these histograms. So as we're going through these histograms, keep in mind that I can do these different paging options with those. Looking at spike histogram, and we go to amplitude histogram, I can show you spike 1 or unit 1 and unit 2 as a histogram of amplitudes. I can go to spike histogram and look at the rate meter, so I can see when they were firing over time. So what this is telling us is over time during my recording, is there any pattern to when in that recording the unit was firing. So you can see that both of these were firing pretty regularly across the entire recording. Some of the other things we have here in spike histogram, we have the autocorrelation. Autocorrelation shows us at 0 seconds here, right in the middle, is there any correlation between the firing at 0 seconds, so 0 seconds representing when a spike fires. If we look in the negative direction in time and the positive direction in time, is there any correlation that we can give to when these spikes will fire? You can see that in Unit 1. We have a pretty clear understanding, again, of my doublet firing. So we have a firing at 0, and then really close to the other ones we have a firing next to it. And then we also have another lull after that doublet. So we gain information from this just by using the histogram. One of the other things that we can do with all of these histograms that I want you to keep in mind as well is that these histograms, the relevant data from these can be extracted. You can, of course, copy and paste these images and use them for presentation, but all of the relevant data, the maximum points, the minimum points, the mean, the standard deviation, all of those things can be extracted, and those can be extracted from by using the datapad. Okay, so the datapad has spike histogram information here, and so my amplitude histogram, my interval, my different plots, all of that information can be extracted using the datapad. Couple more things about spike histogram. We of course have cross correlation. Cross correlation, when you open it at first, is blank because cross correlation requires me to define a unit with which we compare all of the other units. So I'm going to say I want to compare all of the units to Unit 1. Of course, Unit 1 has high correlation. We already know about that. But now we're comparing in this cross correlation Unit 1 versus Unit 2. Okay? And again, if we have multiple channels, Channel 2, Channel 3, Channel 4, Channel 5, those will all be utilizing Unit 1 as their unit of comparison, okay, in the various plots that you'll be seeing. And again, you're going to be choosing that simply by choosing the source here down below. Okay. Now, if we look around at a couple more things, we have the parastimulus time histogram. This is a little bit different. So it's similar to the cross correlation, but what you can do with this is you can actually define other stimulus events. These stimulus events can be based on a stimulator, and you're going to be defining these events the same way we defined events before when we were using the scope view, peak analysis, and those types of things. So any data you can use in one of those features to define an event in general with peak analysis, any of the modules, with spike histogram as well as cycling measurements, you can use those stimulus events as the triggering information for these for the peristimulus time histogram. So very useful tool in terms of comparing these unit firings with other pieces of data. So that's a good rundown of spike histogram. Of course, as we go through here, we already know we can analyze while sampling. One of the other things we can do is, once we've sorted these spikes using spike histogram, we've detected them, and we define them as being different parts of different groups or different units, we can also export this to NeuroExplorer, which gives us a little bit further, and which can let us go a little bit further in terms of the analysis that we can do with those defined units. And you know, again, looking at spike histogram is a great tool for these extracellular recordings where we're defining the events and making them as part of the groups, then calculating or analyzing the timing differences between those events. This is great for extracellular recording, as I said just a second ago, but it's also great for other pieces of data. We've found that spike histogram is a great feature to use for arrhythmia detection on an ECG, for instance. Anytime you want to define, you know, a type of waveform that you want to analyze, we can very often use spike histogram to do that, and it's a great feature to do that. So that right now is going to conclude the webinar. So I hope that you guys got a lot out of this. You were able to get the information you came here for. If you have any questions, please, we don't have any questions at the moment. Nobody's typed anything in there. But if you have some questions, type those into the questions area in the GoToWebinar toolbar. I'll also be monitoring the little chat area if you have something you want to mention or say. And I'll hang around here for a couple minutes and answer any questions that might come up while you guys are thinking about what we've gone through today. Otherwise, if there are no questions, I'd just like to thank you all for coming again to the latest in our Lab Chart Mastery Series webinars. Again, I hope that you guys got a lot out of this, and we'll see you again next time.